like to go over again the first part of determining our longitude, which was to determine our local sidereal time. I'm doing this partially because I'm confused by it, and secondly, possibly you too are confused by it. So let's begin doing that again. I'm going to do it on the simulator. I'm expecting you to go outside and use the great simulator in the sky. The constellations are much bigger than you might expect, so you need to scan a much larger region of the sky than you would normally expect to. But you should still be able to see the patterns of the Big Dipper and the pointer stars and of Cassiopeia, the three stars we'll actually use determining our sidereal time. So I'm going to determine it at Iowa City to be a little different than what it is here. So loading up Sidereal. The sun is shining brightly into my western sky, but it's still a little bit cloudy and still much too bright to be outside the room. So I'm going to get the sky ready for an observing session tonight. So let me see what I will get. And then Iowa City, Iowa already. We'll set the sky by turning off the atmosphere, turning off the dynamic eye adaptation and the stars twinkle. The else there is the same. I'll go to markings and turn on the horizon and cardinal points and go to a perspective projection. Landscape, I'll get rid of the ground, I'll show the fog, will not show the fog, and you notice what I'll use is a background. At any rate, here then is the local horizon in Iowa City, but I'm facing south. You know that both Cassiopeia, the queen of Cassiopeia, the queen of Ethiopia, and the Big Dipper, aka the Plow in Great Britain, are in the north. So I'm outside now with you, and I spin you around to face north. Spinning you real fast so you get dizzy and nauseated because of this fast spin. If you notice, as I do that, I'm immediately lining up with the Big Dipper, which is over here. The pointer stars, Phoebe and Merak, point toward the Big Dipper, which is higher up in the sky, or point toward Polaris, which is higher up in the sky. It's a part of the constellation of the Little Dipper, the brightest star in the Little Dipper. So this ought to be Polaris, right here. So having done that, let's see what we might determine about Cassiopeia. Cassiopeia is higher in the sky, directly across from Polaris, about the same distance as the pointer star, the Big Dipper. Here, it's sort of M-shaped thing. It is led by, as it rotates counterclockwise, is led by Caph, the Caphs. So what is all I'm going to do for it? Well, let me see if I can find out what it's going to do. I'm going to draw the great clock in the sky. I'm going to draw a circle. Like that, which is my great clock. And I'm going to put in the center Polaris. I'll make Polaris a different color. I'll make Polaris a nice blue color. Try to forget the center, so there's Polaris. And I'll put on the hands of the clock. I'll put the hands on in 4 different places. I'll put on the hand that faces straight up, the celestial meridian. I'll put on the hand that faces directly west. Oops. Put on the hand that faces the ground, straight down, and I'll put on the hand that faces east. Now those are the hands of the big clock to point away from Polaris, where this cardinal points in the sky. Away. So, now they will have different labels as I come back to the model. They'll have different labels for the two different means of determining the sidereal time. Using Caph, this will point to 0 hours here. Change the color of it up. And make Caph blue, green. So here is 0 hours. Try and erase it. Hours blue. Now pop in green. For Caph, this is 0 hours. The whole big clock hand is rotating counterclockwise. Remember, these are circumpolar constellations. Don't rise or set at this latitude or latitudes further north, such as Sidereal City. In fact, at the North Pole, all the constellations are circumpolar, none rise or set. Okay, so 0 hours, a quarter of a turn later, that's 1/4 of 24 hours in time, this would be 6 hours. Sidereal time is judged by Caph. This would be 6 hours later, or noon. Sidereal time, I guess you might say, by Caph, and this would be 6 hours later than that, 18. And the 0 is the same thing as 24 hours. Remember, the clock is a 24-hour period. All our arithmetic must be done in modulo 24. It is bringing our numbers down to numbers between 0 and 23 and 29. Now, what about the Caph? Green. Let's make let's see, we use red and blue, green, let's use black for the pointer stars. So this would be actually 11 hours. I can explain that in class. This would be 6 hours later, 17 hours. 6 hours later, 17 or 23 hours. And this is 6 hours later than 23, which is 29 hours. However, if that's bigger than 24, so we can subtract 24 from it. And this is now 5 hours. So the black is according to the pointers. So, now let's go back and see where we put those on our giant clocks. Go back to Sidereal. Oops, got to reset the whole damn thing. I'll set it to reset. on, turn off. Okay, okay. Alright, run business. Now we gotta get rid of the ground. Now I'm going to whirl you around outside, so you're facing north. There's the sun about to set, a couple hours. Now you're looking north outside, and you see the Big Dipper and its pointer star. You also see it a little bit. Here is the Big Dipper, the handle, and the bowl. Pointer stars point directly at Polaris. Clearly, we're not looking up high enough in the sky, so we'll look up higher, more above the horizon, toward the zenith, and there is Polaris. Alpha is a number. Okay, and there's the star we'll care about. Now, if we go even further up, we ought to see the constellation of Cassiopeia. There we recognize it. Here is Beta Caph. Here is known as Caph. We will see the pH. There it is. Now let's see if we can figure out the sidereal time from this. If we read the sidereal time directly from Beta Caph, remember it was 0 hours straight up. We'll be up at this region on the clock face. And it was 6 hours down here. So that looks to be about a third of the way. So I will say that is for Beta Caph. I'd say it's about 2 hours sidereal time. And for the Big Dipper, that position is over here. It looks like about 3, well, it's 23, it's about 26 hours, which comes down into 2 hours. Okay. So now, let's go back and see what this tells us about the time. Close this off, and look back here. We had our green star, Cassiopeia, and it's out here about 2 hours, about a third of the way. And our black stars, the pointers, were here. So those are our two readings. Let's take their average. The average of $26 hours minus 4, averaging 2 hours, and averaging 2 hours to the other star. Gives us an average of 2 hours sidereal time. So that's the end of clip 1.